Hello everyone, I am Ludo, the SGU Program Manager in charge of USpace. Welcome to all of you. I will now open the webinar with some practical information. So first, why are we there today? That's a good question. Basically, because we want to stay connected with you, especially in that period of time. And we think it would be a very good idea to take benefits of the working tools that were ready before the WAC cancellation. So that's why so we basically repeated the working tools in 3 sessions. 2 sessions already took place 2 days ago, and today this is the last session. So the session 1 that is already closed was about the explanation of all the type of activities we have in SESAR regarding USpace, from the concept definition to the demonstration. The second session, already closed as well, was a session very focused on some technical challenges and the type of solution that have been developed by the SESAR projects. Today, this is session 3, the last session, but not the least, because we will speak about the demonstration activity. What does it mean to demonstrate USpace? And you will see the presenters will explain you how they have developed their scenarios and activities and demonstration activities to be close to the real life. So before we let's say dig into the details, it's good to have some rules for these sessions to make them a good time for all of us. First, you see there's a chat. You will discuss between you and with the communication team. If you have any issue, do not hesitate. There is a tab named questions, and this tab is very important for us because this is a way you have to ask any question to the presenter. So please use this tab to put your question during the presentation. We will reply them during the presentation, after the presentation, and at the end of all the presentation, we will take the time we need to wrap up and to take the question as much as we can to share the answer with everybody. In any case, all of you can see the questions that are raised and the answer that are provided by the participants. And finally, there is a section polls. You will see at the time of the Q&A, at the end of the presentations, there are some surveys that will be accessible to you. Please go and provide your answer. That will be a good way for us to keep some feedback from you. So in a few words, what USpace is. USpace, this is a solution for safe and secure drone operation in Europe. Its first definition has been agreed in 2017. Since then, the SGU and its partners work together to develop its concepts and to demonstrate its feasibility. So a few figures here. You see USpace in SESAR. So you can see with all these figures how the research works brought together an amazing number of players from traditional aviation, startups, research institutes, universities, drone operators, service providers, and so far and so on. More than 100 entities work together and share their knowledge, skills, and resources to make this happen. In addition, we, the SGU, we ensure the close cooperation with the European Commission, the EASA, European aviation industry standards such as EuroCAE, Eurocontrol, to ensure that we answer to the needs of all these organizations. In parallel to that, a lot of information sharing has been made with international projects as the project consortiums have been working together with the so-called new entrants. So organizations like GoodMA, Drone Alliance Europe have been consulted or have been part of the projects. And something to be added as well is that for the first time, we went outside the aviation industry, and companies like telecom companies have been part of these projects. So this is a family picture. So I do not have the time to speak about all these projects. You see here the 19 projects from Dreams, Eurodrones, Podium, and so far and so on. I just invite you to go to the SESAR website for more information. There is 1 page per project, and you will have more details for each of them. So a short and complex timeline. It is very important to have this in mind. After the definition of the vision, so I spoke about the blueprint, it was necessary to act and to act very quickly. So almost everything was done in parallel with a short timeline. So 2 years for the projects. This is very short. This was a big challenge for the projects and the SGU. And I don't speak about the coordination with the regulation and installation bodies that were working in parallel as well. So 10 demonstration projects, 8 exploratory projects, one project dedicated to the CONOPS have been launched together. Today, when I'm speaking, almost all of them have delivered their final outcomes. And the SGU is working on the consolidation of these results. Beginning of March, a first document, the USpace brochure, has been released. This is a first version of the results of the projects. You will see the presentation of the projects and the first outcome, the first conclusions. We plan to update this document before the summer with more information. By more information, I mean more conclusions and recommendations coming from the projects, more requirements, the assessment of the maturity of the USpace services, identifications of R&D needs to be addressed in the future. So I said USpace is about, this is the solution for Europe. That's why it was necessary to cover a large spectrum of the geographical possibilities and European characteristics. And we did it. In blue, this is the list of all the countries that have been covered by the SESAR work in USpace. And you can see that we did it from the urban area to the rural area, including airports, maritime, forest, and so far and so on. In addition to this, we had to answer to a lot of operational and technical questions that were floating in the air when we started the projects. Some questions such as, can we use a cellular network for drone operations? Or can we have multiple service providers in the same geographical area at the same time? Or can we use the existing aeronautical information for drone operations? A lot of questions have been answered towards the various research topics that you see in that slide. So here just to highlight some key findings. There are a lot, and this presentation is just an introduction, so I will not dig into the details here, just to pick some of them. You see the first one, the first concept of operation for USpace is ready. We have demonstrated the feasibility of the multiple service provision. The foundation services are successfully demonstrated as well. And there are a lot of findings that you will find in the reports and in the next update of the USpace brochure. Just 3 messages from my side as a program manager that is in charge of all these projects. First, I was very proud to see the strong multi-stakeholder participation. A lot of people have joined the journey thanks to the projects. Here, especially, you see the USpace community network that has been organized by the CORIS project. At the end, it was more than 500 people being present and accepting the initial concept of operation. It is very important for us, as it is very important for us to continue this engagement and to support other forums like the network of USpace demonstrators that has been engaged by the European Commission together with the EASA, Eurocontrol, and the SESAR GU. This network goes beyond the SESAR players and involves more actors in the field that are key to ensure the development of a robust USpace framework. Another message, and that's something that today, just after me, Thomas, will take the floor. USpace is more than a set of services. USpace is an ecosystem, and it's something that we will have to consider in the future to be clear that USpace is a system with dependencies, minimum performances, and data, and we have to consider all the work we do according to this. And finally, USpace is USpace. I mean here that we do not have to do copy-paste from the ATM, even if we have to fully recognize the importance of the ATM, because USpace and ATM have to live together, interfaces are required. USpace will learn and has learned a lot from ATM and will continue to learn. At the same time, USpace has its own specificity, that has to be considered to ensure a proper development of USpace. So that's all for my introduction. Just to remind you to go to the SESAR website, you will find the preliminary version of the use space brochure. You will find a lot of videos. You will find the web pages for the projects, and more will come soon. As I said, an update of the brochure. The project deliverables will be available by this summer. Thank you for your attendance, and I will give the floor to Thomas for his presentation.
Good morning. Thomas Luttes here, Frequentis. I'm speaking for the Gov Consortium, and I'll take it right away. I have 10 minutes to guide you through. Like Ludo said, it's an ecosystem, and looking at the ecosystem in Gov in a validation project, combining existing products or almost ready-made products to a running system, we thought it would make a lot of sense to take it from real-world operations. So instead of designing it on paper, we talked to drone operators and we tried to figure out what they want to do, where they want to do, and how they want to do things. And the whole project was basically centered around 7 demonstrations, and you see them listed in the gray boxes on the bottom. I have not enough time to go in detail. Get in touch if you want to know more with any of the project partners. But in a nutshell, we covered cities. Cities meaning real cities, like in Helsinki, we were flying down in a park, in front of big buildings, in front of European Commission events with lots of people around. We were flying over the sea between Helsinki and Tallinn. So we had one flight crossing the Gulf of Finland, international flight from Tallinn to Helsinki. We were flying in the forest, looking at trees, doing inspection flights, figuring out in which shape, in which condition the forest would be right now. And probably the most famous one, last trial, again in Helsinki, we were flying an urban air mobility scenario with an air taxi. It's been 19 partners, very heterogeneous environment, ANSPs, USPs, drone operators, infrastructure providers, authorities, consulting companies, from a small startup with 2 people up to large organizations with a few hundred people. The whole meaning of it was to make everybody aware of the situation. So everybody in these trials, from drone operator to USSPs to ANSPs, should have the same common operational picture. Because only if you make people see the same thing, or systems see the same thing, this whole environment ecosystem will work. And looking at the diamond at the next slide, this is the high-level architecture that we've come up with. Ludo had the detailed ecosystem before. What it shall emphasize is that in the end, it's about information. Information needs to be shared between stakeholders. And in the setup that we had in Gov, services that perform work, that offer results to drone operators, because this is in the end why we are doing this, to enable drone operators to do their business in a safe way. So those services offer the drone operators, some of them, they can run multiple times in the same area, in our opinion. They can be tailored to the specific need of operators, to the specific needs maybe of environments of countries. And some of those services, they might need a specific focus on one area. Single source of truth was one of the keywords that we came up with in the validations and in the wrap-ups afterwards. For some things that only exist once in space, you probably need one service dealing with them. That not necessarily means that it's a centralized service or fully centralized service. It just needs to be clear on who does what. And what we did, we reused Swim concepts that's already in place for quite a while. I need to be very precise. Gov was built based on Swim principles, and that means we took the concept of information exchange services, and we took the concept of which elements should be on those services and how to document them. Given the short amount of time that we had in the project execution, we tried to speed up, but still we put very much focus, like for the project goal, on making people understand, on making systems understand. So we had a multi-step approach. First, looking at the use cases, looking at the demonstrations, we tried to reach a common understanding. What's the data that we need? which services would we need to exchange that data, and what do we need to describe to make people aware what this service actually do. What we found out, if we leave out technology in the first step and just talk on a logical level, this is a flight plan, this is a surveillance record, a telemetry record, a drone position. This is how this data model looks like it has latitude, longitude, altitude, coordinate reference systems, things like that. If you talk about the interface, I can ask this service and it will provide an answer. I can subscribe at the service and it will provide me updates. But do not talk in the first step on technology. It makes it easier to understand, to reach agreement. Once we had the basics covered, the basics meaning context, model, interface, behavior, we moved on to technical things. And that's a second step that enabled us to integrate existing technical interfaces, software that was already there, that was already running on productive systems, to integrate these interfaces by mapping it to the service specifications that we wrote. We focused on the key elements. So we had service specifications written and delivered for telemetry, surveillance data, flight plans, context information. Back then we called it EM geofences, for alerting, communication between operators and managing systems, and of course for registration data. This started like 2 years ago. So back then the draft opinion was still a very much draft. You need to put it in the timeline to see the context. So things that we did and things that should produce and did produce tangible results for drone operators. We actually demonstrated dynamic geofencing in a park in Helsinki in the last shot on that specific day. We simulated a policeman to put up a geofence and then saw the drone moving away. Let me see if the animation works. Yeah, not really. Oh, it does. Bubble around the policeman, drone moving out. And we could see this happening within seconds. So it was nothing that took long. It was just click, see the results immediately. And it was quite a wow effect to see a combination of 10 systems doing something within the short amount of time. We've seen the common display achieved. So on the small screen on the right, you see several displays that were involved in the demonstrations. And all of them, that's the red dot that you see, all of them have been showing the same situation, the same surveillance data, from drone operator screens up to ANSP displays. We achieved flight plan sharing. So one partner created a flight plan. We called it operation plan. And that operation plan was sent to another partner to approve this flight plan. And we did in-flight plan changes. So in-flight flight plan changes. What does it mean? Using mobile network, we were able to provide context information near real time. Pictures are more fun. So this is a few things from the demonstrations. The big one in the middle, that's a capture from the drone going from Tallinn to Helsinki. And allow me to highlight a few things. You see it's been going quite fast, upper right corner. You see it's been going quite high, around 1,300 meters above main sea level. And left side, you see on screens the geofence we put around. You see, if you look really close, you see the drone flying. On the right-hand side, you see from the post-processing how the drone moved up to that level so that it could fly in a straight line over the Gulf. And what you really can see, this is quite mature stuff in operations. Can the systems keep up with? I think for basic levels, we are already there, but still to reach operations that it needs a bit of more validation, but that's stuff that's anyway ongoing now in current calls. So enough talking, allow me to share a video that gives you probably a better impression of how we did it. And you will see it's been real life stuff. So people moving around, lots of talks, lots of interaction in a real world environment. Moving on to the video. A bit over time, so I need to be fast in saying so much for golf. In case you've got questions, post them. I already see a few. And that means I do apologize, and I think I hand over to Hank and say goodbye.
Thank you, Thomas, for this presentation. Yes, please use the questions tab to ask any question to Thomas or in general. I will pass the floor to Hank.
Good morning, everyone. My name is Henk Hesselink of NLR, and I will present the results of the Fedora project. Fedora was also one of this SESAR very large demonstration projects where we together tested use space by applying this in settings in urban and rural areas. And we worked with several use space service providers to see how this would work together. First of all, when flying a drone, this needs to be organized. If I fly one drone and I know for sure there is nothing else in the area, that can be easy. I can be sure that there is no other traffic, and I'm sure that I will not hit anything. With 2 drones, well, it's possible to align as well. But if we talk about 3 drones or more, future visions talk about hundreds or even 10,000s of drones simultaneously, we need to organize this. Now, this is done by use space and by the use space service providers. Just like on the road, we have traffic lights. Just like in the air, we have air traffic control. Use space offers the possibility to organize the traffic of drones in a very different way by providing services. In this project, we investigated how these services would work. And specifically, we foresee an open market. Already many service providers are providing products or part of products. And it is good to investigate how these can work together. We investigated this in a consortium of 10 partners. So we're with NLR, the Technical University of Delft, the city of Enschede, and we were very glad to work together with LVNL, the Netherlands navigation service provider. We had 2 use space service providers, Unifly and AirMap, who cooperated in this project and had to exchange information. And we worked together with industry in UAV International, AirHub, Robo Electronics, and Unisphere. On the picture, you see that we had 3 demonstrations. These were real demonstrations where we invited audience who were capable of observing how we work together and how the use space could provide its services in the Netherlands. The first demonstration was at NRTC, which is a test site, the NLR Airpass Test Center in a rural area. So we had a lot of space where we flew 3 drones simultaneously that were organized by 2 use space service providers. The use space service providers had both a separate area where they were organizing the traffic, while we had 1 drone that was passing through both areas, so some coordination needed to take place. The second demonstration was in Delft, where we flew in an urban area, actually above the city or the university campus, where again, the 2 use space service providers showed they were capable of dealing with 5 drones simultaneously. And in this situation, the area was shared with the service providers, so 2 drones were under control of 1 use space service provider and 3 drones under control of the other. And they had to coordinate the traffic to ensure that the plans were aligned and that they did not collide. An interesting aspect here was that we were flying in the CTR of Rotterdam, and that means that a navigation service provider was involved, and actually the system was capable of presenting the flights at the control tower of Rotterdam, and the air traffic controllers were actively involved by approving the flights. The final demonstration was for us the big demonstration in Enschede in the east of the Netherlands, again in an urban area with 5 drones and 2 use-based service providers. And here we linked to the Smart Cities initiative. Enschede is one of the cities that has signed this initiative. In fact, it is also signed the Urban Air Mobility Initiative. So yeah, we tested everything together there and showed how that would work in a smart city environment. For each of the scenarios, we included a priority flight. And that was one of the things we also wanted to investigate is how does that work if we have a number of flights already operating and all of a sudden some flight needs to pass by which has a higher priority than the others. Now, I'd like to show a small video.
Drone traffic increases every day.
I think you can
It
see
is
it now.
vital to have a framework in place that guarantees the safety, privacy, and security of
Yes, we see
everyone
it.
involved. The Fedora project tests and demonstrates the technical and economic
Now,
viability
it has some
of
spectacular
commercial drone flights,
footage. I
including
think
flights that
what
are
you
beyond
see
visual
next
line of
is
sight. To execute
drones
this,
flying
a
over
common
the
use
city
space
and
framework
one
is
drone
required with
filming the
U1
other,
and U2 services. This allows multiple use-based service
which I think
providers
is
to
quite a
support the
nice,
safe integration
nice
of drones
picture.
into a shared airspace. The demonstration of the Fedora project showcases drone scenarios in rural, urban, and smart city environments. Each scenario features 2 service providers coordinating their services. Other realistic elements are also included: manned aviation, different levels of automation, commercial and leisure drones, off-the-shelf drones, as well as custom-made ones. During the demonstration, these drones will have to safely make way for the high-priority AED drone. They will also do this autonomously. Fedora is a SESAR CEF project. It supports U-Space, the European vision for the safe, secure, and efficient management of drone traffic. Its goal is to enable the drone market's growth by demonstrating the economic and societal benefits that drones can offer. Led by NLR, the project cooperates closely with the civil aviation authorities. The flight demonstrations will take place at Delft, Marknesse, and Enschede, all in the Netherlands.
So you can find more information on the website and go back to the presentation. So we had a number of challenges in Fedora. We were flying beyond visual line of sight and we didn't make it easy for ourselves. So in Enschede, we flew 3 kilometers between the airport and the city, where in the middle, beyond visual line of sight, 2 drones would meet. One was flying in one direction, one in the other. And through the U-Space system, they had to avoid each other. That worked fine. We also worked with different communication systems. We had a transponder on board of one of the drones. We had a system that was capable of sending its position to the 4G network. We also connected the ground stations directly to the drones. So, assembled everything together in a U-Space where we had a common vision of where everything is flying and where all the drones were operating so they could avoid each other. Now, for the priority drones, that was one of the main topics that we thought would be interesting to further investigate. We had an automatic defibrillator drone and we had a firefighting drone that was getting an overview of a fire situation. You see them on the pictures here. These are actors, so it's not a real situation, luckily. And we tested different settings. First of all, we tested the strategic conflict detection between drones. So the priority drone was planning its flight, providing the information to the U-Space, and through the U-Space, the other drone pilots were informed and cleared the way for the emergency drone. Once the path was cleared, the pilots of the other flights informed through the U-Space system the emergency drone, and the emergency drone could take off knowing that the area was clear to fly. This is quite a complex process. It takes about 2 minutes, which was reasonably long, but for most emergency probably possible. In the next demonstration, we demonstrated tactical planning. That means that the drone would take off automatically. It was in the Delft scenario, so it had to request a permission from the air traffic control, which took about 15 seconds. Then the drone planned its flight autonomously, and when it was in the vicinity of other drones, through information that they received from the U-Space system, they were capable of seeing each other, detecting each other, and an onboard system then would avoid the conflicts. In the final demonstration, we had a tactical deployment of a drone, which was brought by the firefighters. They immediately deployed the drone, and the drone emitted a no-fly zone around its position, and thus informing other drones that they had to leave this area, or at least clear the area that was near the drone. We demonstrated that because there was a journalist drone that also saw the fire and wanted to make pictures. Well, the firefighters have a priority in that case, and they were capable of clearing the path through automatic conflict detection with the journalist drone by sending the no-fly zone. So concluding with 3 demonstrations, the main achievements were that we really thought about how can this be done safely. We found about 50 safety considerations for the 3 demonstrations, and we required 25 waivers, so 25 formal rules in the current regulations concerning the use of drones. We needed to get permission from the formal authorities to ensure that we were not following these rules, but we had permission because we were capable of doing it safely and were able to fly. We showed it to U-Space service providers. There were 13 different drone scenarios, and altogether, including the tests, we flew about 100 flights. So together in Fedora, we demonstrated the first possibilities of the use of high priority situations in drones, and it's a topic that we will take up further. Very interesting and very important for the future of U-Space. Thank you.
Thank you, Henk. So you will see that there are already some questions to you in the questions tab. A good opportunity for me to remind to the participants to use the questions tab rather the chat to ask a question to the presenters, because we do not look the chat during the presentation. Now I will pass the floor to Hélène.
Hello, Ludo, and thank you for inviting me. I will share my screen with you and start the presentation without further delay. Can you see the presentation?
Yes, we see it perfectly.
Okay, perfect, wonderful news. So thank you so much for joining me. I'm Ellen from Unifly, and I would like to tell you a little bit more about the SAFIR project. SAFIR stood for Safe and Flexible Integration of Initial Use-Based Services in a Real Environment. Also, to my knowledge, this is the only project that we have that has an acronym for the actual first letters. So there we are also very proud of that. We, in SAFIR, demonstrated the safety and the economic viability of drone use in challenging environments. So we connected 3 use-based service providers and also the Belgian National Air Navigation Service Provider. The goal was to jointly control the airspace. So as you will see on the next slide, SAFIR was mostly active in the port of Antwerp, but also over the actual city of Antwerp and even in the extended runway of the Antwerp International Airport. So before we went there, obviously safety was our main concern, and we first successfully tested all the use cases in the state-of-the-art secure test environment called Dromeport in the east of Belgium. So only when we were completely satisfied with the robustness and the outcome of the test did we move to the larger Antwerp environment, where we continue to test the viability of these use cases in a more realistic environment. So we had quite a few use cases because, as you can tell, it is a rather large consortium. Unifly led the consortium, and in total we were 13, both public and private organizations. So it would take me too far, and it would definitely take more than 10 minutes to list all the contributions of all these companies. But I would like to take the opportunity to give you a very high-level overview of what we accomplished within SAFIR. So here you can see an overview of all the flight paths, or practically all the flight paths. There are some in the south of Antwerp that are outside of this picture. So you can see the medical delivery flight at the lower right-hand side. You can also see how large the harbor is and how many operations took place in the port of Antwerp. At the top right-hand side, you see a very large red ball. That's actually a no-fly area because we had the nuclear plants that are there from the harbor, so that would have been far too dangerous to start flying there in the vicinity. I would like to show you a brief video just to give you a little bit more of an idea what it actually looked like, so it's not so static. Here it should be appearing on your screen shortly. There we go. There is no sound because I am just going to tell you what is happening in the video. So as I told you, we had 18 flights, and we had use cases in a couple areas, including delivery, also medical delivery. We did inspection, we did mapping of power lines and of environmental infrastructure. We also had surveillance and monitoring in the port, for instance, both for air spills and for emission levels, to ensure that the activities that take place in the port of Antwerp could include drones in a way that makes sense, not because it's safe, but also because it makes economic sense. It's the best way to do it. So the harbor master could actually request the drones to go and inspect the places where he suspected that something required further looking into. So we had, of course, drone technology companies, we had use-based service providers, but we also had a couple other specialized companies who joined us and made SAFIR a success also with their technologies. So we evaluated the use of telecommunications for data communication, because if you add all the drone operations as part of an Internet of Flying Things, you want to ensure that you don't interfere with existing mobile phone data and vice versa. So we provided the UTM technology, supporting the drone operators to plan and execute the flights and make sure that they adhere to the applicable legislation. So the authorities could monitor the flights, could track the drones, and they could also intervene if it was necessary. Now, as I mentioned, there are 3 use-based service providers involved, because realistically, it is not going to be just one party who is going to control the airspace. So if we want to have drones in a safe way, in a realistic way, then you have to have this collaboration between the various systems, as Henk has already also pointed out, because that is the only way that it is going to be in the future. So we have to make sure that we are ready for that. So the connection between these systems made sure that all the drones were aware of any need for necessary deconfliction. We also demonstrated over the city the medical flights, which, especially in an urban area where there are often congested places, sometimes time is of the essence, and drones are a very useful addition there. Likewise, in the port of Antwerp, you are looking at an incredibly large area with critical infrastructure. Here you can actually see what the system picked up. I will show a little bit more about that in just the future. So especially in critical infrastructure, every second counts. So the SAFIR really proved that the addition of drones is really critical to the increased safety, because the port authorities are able to manage and inspect their area, and they can do it really, really quickly. Voila. So that was the short video that I wanted to show you. And now, as promised, I will show you a little bit more from the system. Can you see it okay on the screen? I can see it, but I'm not sure.
Yes, we can see it.
Yes, you can see it. Okay, that's great. Some people who were there yesterday may maybe recognized it a little bit from the class webinar yesterday, but as you can see from the background, we are now in the harbor. You can see the silos and you can see the river. So the low-level radar there picks up all the movements that are there in a given area, and they are able to tell based on the movements if something is likely to be a drone or if it is a flock of birds or something else. So now you can see the things indicated are red. In red are small drones. You can see the little icons there as well. Because drones are not only useful within a port area, but they are also a potential threat. I don't need to bring to mind the example of the airports that we have all seen. So if you're in a critical infrastructure area, it is vital to be able to detect all the air traffic. You have to be able to determine if they are supposed to be there, who they are. So that's why we used the radar for all these aerial movements. And here you can see how they actually did that based on Doppler and other technologies to determine if something is likely to be a drone, and if it is a drone, if it is likely to be a threat. So here you can see, oh, that was a bit too quickly, but there you can see the parameters that you can put yourself. So the system calculates the likelihood of something being a drone. And here we see the translation of all these data into the Unifly system, where we merge the data that we have from the tracking, the data that we have from the radar, to see if something is a drone, and if so, if any actions are required. Let me go back to my presentation somehow. I think if I click here, do you see my screen now?
We see your desktop.
You see my desktop, that's good. I will take that.
And for your information, in the
there we go.
meantime, Daniel has joined the stage.
I have seen it indeed. So I just want to conclude by giving you an inside peek of what it was for us to work there. So we had the operations center in the port of Antwerp, and here we combined the views from all these systems. So you can see we had them all one alongside the other to be able to assure that it all worked exactly as it should be working, and also to be able to react immediately if anything went off schedule, which thankfully it didn't, but we were prepared in case it did. So we spent a lot of time there, some very long days, and we had a lot of effort put into that. So I want to take this opportunity again to thank all our partners for this experience. And I want to conclude that within SAFIR, we proved that drones have many potential use cases, especially in challenging circumstances. And in SAFIR, we demonstrated that multiple drones from different operators with separate UTM systems can safely and simultaneously occupy the same airspace. So together, we demonstrated interoperable, harmonized, standardized use-based services, and they were deployed in a safe and reliable way. We are sure what can be done in Antwerp can be done across Europe, and we hope that the work that we did in SAFIR can serve as a basis for the further development of U-Space. Thank you, Ludo.
Thank you, Hélène, for your nice presentation. And welcome, Daniel. So, Hélène, you will see that there are already some questions to you. You will be back on stage after Daniel's presentation to discuss with the other presenters. Thank you.
Good morning to everyone. I will try to catch up the schedule, and thank you for having Domus the opportunity to do this presentation. Okay. So, well, I'm Daniel Garcia Monteavaro. I work in NIRE, and I'm going to present the practical use cases in Domus. The Domus scope, as you can see, was the use-space initial services. U1 and U2, and in addition, some specific U3 services like tactical deconfliction that manages the conflict between drones in case there is a collision risk, and collaborative service with their traffic control system, where there is a data exchange between USpace and their traffic control system. Domus also addressed a smart city use case and had up to 3 different USpace service providers in the same area. Domus members, shown on the right, represent all the stakeholders that are needed for handling USpace, such as technology providers, USpace service provider, technical consultancies, etc., totaling 17 members. Okay. In this image, you can see the architecture using Domus for USpace deployment. The main concept is that the ecosystem manager is the core of the USpace operated by a national entity that could be an air navigation service provider or another entity. It handles the critical parts of the system, such as safety, security, and privacy. Below the ecosystem manager, we have a federated approach, where each USpace service provider is the interface between the drone operator and the ecosystem manager. Each drone operator connects to a USP or USpace service provider to receive USpace services. As you can see on the left, the ecosystem manager acts as a proxy between the USpace and their traffic control system. That means that neither the drone pilot nor the USpace service provider can talk or exchange data with their traffic control. This has to be done through the ecosystem manager. It's very similar to the common information service that is in the opinion, actually. Other stakeholders, shown on the right, like privileged users and authorities, would connect directly to the ecosystem manager, for instance, either to take traffic information or define temporary no-flight drones areas. Let's move now to the first of the practical use cases we are going to present. In this case, with recreational drones without flight plan. What does this mean? This means that the pilot is not going to contract any service directly from a USpace service provider, and its position is going to be known by the ecosystem manager through the remote identification on board of the drone. So what happens in case of emergency? For instance, the need for a helicopter to land close to the same area. The pilot would then receive an alert on the mobile phone, and that's one of the things we did during the demonstrations. Now, the second use case I want to mention here is the tactical deconfliction. So how do we manage a tactical deconflict 5 flights at the same time during the demonstrations? Well, as you can see in the picture, during the demonstration, 2 drones from different USpace service provider had a collision risk situation and were coordinated using the central figure of the ecosystem manager that coordinates the position between the different drones and alert the pilots that they are from 2 different USpace service providers. Looking at the central picture, if a drone lifts its flight plan, in this example, the orange one, in that very moment, the tactical deconfliction module at the ecosystem manager starts to calculate if there is any collision risk with other drones. And if that's the case, alarms are sent by the ecosystem manager to each drone through the USpace service provider. So the information is always through the USpace service provider. On the right, you can see an example of an alert from a pilot screen point of view. The blue area is the flight plan. The red arrow, that is very little, is the pilot's drone, and the red X is the intruder's drone. There is also a red alert warning on the top, so the pilot is aware of the situation. And now let's see the last case we are going to present in this presentation. One of the main values of the project was the development of the interface between the USpace and the traffic control system in an area. On the left, the black screen is from their traffic controller position, and during the demonstration, the traffic controller has to draw a purple area to create an off-flight drone area for emergency reasons. And it was automatically reflected and sent to the USpace, and therefore to all drones that were close by. On the right, there is a visual example of data exchange between the traffic control system and USpace. The drone position in A letter is known by the USpace, and that position is sent to the traffic control screen where letter B, as is shown with the blue arrow. And the other way around, The position of aircrafts that are shown at letter C are known by their traffic control system and are sent to the US space and shown where you see the letter D. This new picture on the right shows an example of an alert in red on the traffic control screen. The name of this alert is geoff and indicates there is a trespasser in the area called a geofence alert. It has to be noted that in order to not increase their traffic control workload, only alarm information for drones should be shown on the screen. Well, as main inputs, the demonstration has been articulated by a highly modular federated architecture. That modularity tested in Domus is challenging, but brings flexibility as well as resilience and robustness to support interconnected USB systems. Some interested future R&D needs after Domus experience are airspace with some special requirements beyond emergency zones. For instance, not only permission for entrance, but to put other requirements like flight performance, position performance, etc. Different sets of flight rules within certain geofences. Emergency zone example. How can we deconflict drones with special permissions to fly into the same emergency zone? Flight plan, in-flight modifications, consequences. How affect to other users a flight plan modifications? Again, it's linked with the tactical deconfliction. Dynamic geofencing wasn't addressed in Domus, and it's a U3 service. And it's important the update of tactical situational awareness directly into the drone. And of course, scalability in this very large demonstration. How your space projects did with hundreds of thousands of drones. That is something to be important to take into consideration. So, okay, this is the end of my presentation. And if you need more information, these live demonstrations are available in YouTube and in our channel. And it's very easy to find them. You have to write Domus with SESAR or US Space, and that's it. Thank you so much, and I will be very happy to answer any question.
So this is the last presentation for this session. So I will now invite Hélène, Henk, and Thomas to join us on the stage. I think if it is not already done, Remy will probably open the polls, and then you are kindly invited to go to the polls tab and answer you, which is a very simple question, but very useful for us to understand your needs and your feedback about the webinars and the work we do in SESAR. So I see that Henk is not there yet. There are a lot of questions. Clearly we'll not be able to answer to everything here, so the idea is not to answer to everything, just to pick some of them and to have a small discussion, or at least to share the views from the presenters. I will pick some if I saw that Hélène, Henk, Thomas already answered to a lot of questions. Thank you for that. I just I saw one of them. I was thinking, oh, maybe I will start with this one. It was about yes, what is the approach used to maintain drones safely separated by all the airspace users? So especially with the VFR manned aviation in uncontrolled airspace. Is it something that you have addressed or at least thought about? And what is your position on this? Who wants to start?
Well,
feel free to. Yes, Hélène.
I'm happy to start. We had collision alerting as part of the UTM system. So both the drone operators and the authorities were aware of the vicinity of any other possible aerial vehicles via the UTM system. And there we made sure to take the decisions based on the specific instructions that are connected. So for instance, in the vicinity of a helicopter, are we supposed to land? Are we supposed to fly to a safer area? It depends on the various flight plans. But we were via the skies, the Belgian ANSP, we were connected with manned aviation at all times.
To add to that, I think that was in almost every VLD. In GOF, we had one demonstration where we had general aviation flying, model fires flying, a lot of drones flying on a real airport. The air taxi flight was on Helsinki-Vantaa Airport, and integrations are natural if you try things like this. And on the one trial where we had generation, we intentionally tried to break things, like Aaron said, including collision alerts and including safety nets. Without it, just wouldn't work.
Yes, I agree. And even though we should think further about this issue as maybe how to ensure that manned aviation is also aware of what the drones are doing, so we can also reverse this. In it's more a question for the future, and how to make sure that manned aviation is aware of what drones are doing, and U-Space can offer a good solution for this.
Okay, for Domus' point of view, what we did was that we used the ADS-B output of the. Okay, sorry, I have a problem with the connection. What we did was to use the ADS-B on board of an aircraft, and when the aircraft went below the very low level, it started to create a geofence around the main aircraft. So all the drones were alerted and have to separate for the manned aviation. But if the manned aviation is above the very low level, there is no alerts and not any kind of interaction.
Okay, so maybe to extend this question, and this is in relation to, I saw a lot of questions around this. Clearly, we are not, let's say, the decision makers. We are not in charge of the regulation or any kind of application like this. But the question is, what about generalization, rotorcraft? Do you think that based on the work you did, such vehicles should be using U-Space as the drones when they are in uncontrolled airspace?
I think one of the key concepts, if I may start this time, is that any aircraft shall be conspicuous, so visible to others. And maybe it's less about naming of how the environment is named, and less about categorizing into manned, unmanned, whatever. When we brainstormed in the very beginning, in the end, it's one space, and there's one famous paper like "We are one in the sky," and I think that's the best possible summary. Systems need to cooperate; they need to talk together. The ecosystem needs to be as integrated as we can achieve safely as early as possible. So I'm not sure if that's the precise short yes/no answer that people were expecting, but clearly systems have to talk to each other.
Yeah, if I may add to that, I think you make a very good remark that people need to be aware of each other and of each other's activities, and U-Space is maybe even you don't need to apply the full U-Space for this, but the nice thing about U-Space is that it offers services, and you could connect to maybe just one of the services, like the surveillance service, and get information of the full traffic without the need for a full deployment of U-Space for other traffic.
Yeah, to add to that, I also think we all demonstrated the need for collaboration and openness. And I would like to stress the importance of standardization. We need some type of standards that everybody agrees to and adheres to ensure that we have one single way of working that is approved by at least all the member states, and preferably even across the oceans as well. Okay. Because today, well, we can monitor, of course, but especially standards will need to be further developed.
Daniel, okay. Something to?
Yes, you touch a very hot topic, because there's some discussions if the helicopters or other aircraft has to be equipment or to spend money in new equipment or in something that nowadays they don't have to. Okay, so it's a big deal, because there is not only the idea of to provide services. Because we have a problem with the surveillance. These vehicles in non-controller space, they don't have usually surveillance, nor ADS-B, nor transponder, because of the height, because they fly very low. So it is very difficult, the conspicuity that it has been told. So they should be inside the U space. Okay, in that cases, because we don't have the normal or the normal surveillance information, and that means that they have to pay for that service, and it's something that, well, it had to be developed, and as I said, it's a hot topic.
Yes, indeed. And the aim in SESAR was not to answer to this question. I mean, we had, as I said in my introduction, we had a lot of questions floating in the air when we started the projects. Unfortunately, we were not able to embark all of them, and this one is probably something to be addressed in the next steps. Speaking about the next steps, there is one question that I would like to extend a little bit about the position of the national authority to handle the next use space steps and when. So I will not ask you, except if you have some information here, but I would like to transform this question into the following one. You have shown your projects, your systems, the use cases, the companies that have been involved. We have shown the videos that are very tangible. Are there some? What are the next steps? I mean, starting from what you achieved here, do you have any plan, any use cases that will continue, that you will exploit? How will you exploit the work done in your projects after the closure of these projects? Are there some plans, some ideas, or some already actions in that sense?
I would be happy to answer that. As part of what we recognized in SAFIR, we saw that there is a very clear need to be able to protect critical infrastructure, and there is also a very clear need for the drone operation or the drone services market as a whole to have this secure connection to the authority and to be able to plan and manage their drones and their flights in one place. So that's where we as Unifly feel that there is something that we can deliver there. So for us, that was a very interesting area to explore.
So maybe I follow up with Ellen's comment. I very much agree. I've been in a few projects, commercial and research, and I've really learned so much as in last year's project. And due to time reasons, if you look at the slides that we will upload afterwards, you'll see the partner list of GOV as well. And as Ellen you see on the screen, Unify was a partner. And I think looking at all the videos, I recognize faces, I recognize people. And I remember what I've seen, I've learned, and what we already now use in applications for future research projects, as well as in commercial projects. So maybe that's time to turn around and say, thank you, Ludo, thank you, SESAR, for making this happen, because I think this push that we've seen in the last 2 years, it can't be valued enough. Coordinating 20 projects in 2 years to bring that speed and that grip on things in, that's definitely an achievement that we, I think, have not seen before in this domain. Yeah, exactly.
Thank you.
Yes, well, from a Spain point of view, and I represent the National Air Navigation Service provider. We are working very close with the national authorities and member state. Okay, at the member state representatives for the European Commission and EASA opinion. And at the same time, where we are participating in other projects and trying new concepts and new ideas in US space.
Thank you.
For us, it's similar. I can so subscribe to the remarks made that we need further standardization and we need to make this further operational. In fact, in the Netherlands, the first version of the use space is now available. For the research part, I can also add that we will further investigate how to use it. Still, many things are open. How is the coordination between all the tracks ongoing? We will further look at priorities. We have different priorities. Some priorities are more important than others. Maybe that's things we are going to investigate, and specifically also the BVLOS possibility for flights, and the possibility that U-Space offers to make this possible.
Yeah, so still a lot of work to do. So maybe to close this question, I just would like to mention that yes, I think a lot has been done during these projects and the 19 projects together. At the end of these projects, we have a kind of mixed feeling, because on one hand we are very happy to see all the work that has been done within this short period of time. So as I said in my introduction, we are consolidating the results, and we target to update the brochure with a lot of information coming from the project reports by this summer. And at the same time, we feel that there's still a lot to do. And that's why the future R&D needs and the material that has been developed during these projects will be as much as possible published. You will see all the specifications, because there are some questions about this in the set of questions, the technical specifications, the performance, and so forth and so on. All the project consortiums agreed to disseminate as much as possible. So a lot of documents will be available by the summer. And I would like to thank you, to thank all the projects for this good willing to share their work with the community. I'm not necessarily taking the most easier questions, but there is some questions about the multiple service provision. I saw that Hélène answered to one of them just a few seconds ago. You have several use space providers, but in case of conflicts, in terms of who has the final authority, how do you deal with that?
The final authority is the CAA. So even though the use-based service providers provide the service, it is up to the actual authority to determine who has the priority. So further along, it will be that, like we saw in the Fedora project with the AED drone and also the fire department drone, depending on the type of operation, one drone will take precedence over another. Like in the same way that we saw with the medical delivery flights, a medical delivery will take priority over another delivery.
Yes, I agree with that, and still a lot of things need to be further investigated. We've demonstrated the idea, and now we need to take this up further, because what would happen if I have a priority package delivery for myself? Is that priority as well, or how much priority will that get? That's typical questions we need to further investigate, and there's I agree with Ellen, the authorities that need to make decisions on this.
I think it's like we had on a few slides in the Gov project. I think the key part is knowing who, knowing where, knowing when, and clearly making it transparent to all the users who's responsible in which action. And I think that's part that is already starting to shape out in the regulation. But it's not black or white. I think Ludo said a few months ago, flexible but strong should be something that we go for. It needs to be flexible enough to keep this whole ecosystem going, to keep it open, to make it something that really flourishes and lives. And it needs to be strong enough and to provide a frame that makes things happen in a safe way. And finding this balance, this is something that I fully agree with Hank needs to be investigated. And it's good to see you all on screen. And it's like ongoing meetings, new calls, and new collaborations projects ongoing. So I think we're on a good way to investigate it. But it's still a few steps to go.
Yeah, indeed. I pick one question here about standardization. So there's a question from Miguel Aguilera on standardization. Do you think that specific standards guidelines for developing APIs for use space are needed, or can we just take material coming from other domains like the telecom?
I absolutely think these standards should be coming from the area of aviation, such as the swim standards. I don't think it is viable to see which commercial standard is going to come up somehow if people are going to try to create the IP for that or try to monetize on that some way. I think this is something that has to come from the authorities.
Thank you, Hélène. Very clear. Somebody wants to react on that?
Not many things to add here. There's for sure a lot of commercial aspects in that environment, and commercial payload is an important thing to make this whole thing work. But for the key things of safety related services, for the essence of use space, that's definitely aviation. Yeah.
And it's a process we need to start quickly, specifically for some of the services as e-identification. How will that work? We're all drones provide their own identification, or do we need standards for that? I think we do, and let's work on that. But for other services as well, that can be done separately.
I try to scroll down to see the questions, but I know that there are a lot of questions. I think so. We are going close to the end. Except if you presenters you saw questions that you would like to highlight here. I'm checking. There are a lot of questions that are still not answered. We will do our best to answer to the questions after the session, and to publish them, to publish the question and answer in a few days. So don't wait for that. I'm checking. Some of them are very detailed and dedicated to one of your projects. So I think we can close here. I will say a warm thank you to you presenters for your presentation. You are closing here the session 3 of the first SESAR webinar. It was a good experience. Thank you for your work, and I would like to thank you all the participants that were there, that are still there for the Q&A. I think we will close. I will just ask Remy if everything is okay on his side, or if there are some additional information to give before we close the session.
No, that's fine. Just if you want to complete the polls tab, there are 4 questions if you want. So I just leave the webinar open for another minute or so.
Okay, so as Remy said, go to the poll if you didn't do it. Thank you again to the participants. Clap to you and to session 1, 2, and 3. It was a pleasure, real pleasure to see your faces and to see your presentation, to see the videos and see all the people that have been working on the SESAR projects over the past years. It was very nice for me to see these faces and these people. So thank you a lot. We close this session, and so we stay in touch. As I said, more will come soon in the coming weeks and months. We will publish additional material. Thank you all. Bye bye. Take care.
Okay, bye.
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 Thank you.